Hello everyone, welcome to Amplify Programming. In this video, I am going to show you how you can create a circuit design in Tinkercad for simple IoT experiments. So now you can click on this design. So as of now this design is empty because I have not created any design here. So as of now I am going to concentrate on designing circuits for simple IoT projects. So let me click on circuits. Then you click on create button to choose circuits option. So once you choose that, you will be redirected to the dashboard where you can view the options for adding the components for designing your circuit. So first change the name of your design. So let it be LED blink. So I have created I am going to create or design a circuit with Arduino Uno board and LED to make the LED to blink based on time delay. So for that I need the various components like breadboard, then Arduino Uno board, and then the LED. So here we have LED. Additionally, I need a resistor to connect the LED to the Arduino Uno board. So if you look at the right side panel, you have various components including the sensors. So you can try with different sensors, and you can write the code and look into the output by starting the simulation. So as of now, let me tell you how you can design a circuit for making LED to blink. So first let me insert a breadboard. You just click on this breadboard icon. So here I have the breadboard. Next I need Arduino Uno board. You just click on it, so it appears here. So you can resize the working area. I mean, you can zoom in or zoom out as per your requirement. So next I need an LED. So let me place it here. So before that, let me tell you something about the breadboard. So we have these four panels here. So the top two and bottom two columns represents the positive and negative terminals. So this is used for connecting your sensor, the negative side of the sensor to the ground pin of your Arduino board. Similarly, positive to the either to the supply voltage or to the IO pin. So if you want to connect to the supply voltage pin, then you can connect it to the positive uh, positive terminal here, and then from this you can connect to the supply voltage on the Arduino Uno board. So the other you have 4 plus 4, 8 columns we have starting from A up to J. So all these columns can be used for connecting your sensor component to the Arduino board through the connection channels. So please don't use these positive negative uh, columns to connect to the input output pin of the Arduino Uno board. So this is only for connecting the ground and supply. of your Arduino Uno board. So let me demonstrate you with a simple example. So I have placed the LED on column J. So now I need, so you have two terminals here. One is cathode, another one is anode. So anode represents positive terminal, cathode represents negative terminal. So always the negative should be connected to the ground pin of Arduino Uno board. So you have another column below the cathode. So just click here so that you can get the connection line. You can directly connect here. I am connecting it to the ground pin. Whereas for the positive side, I need an additional resistor because the uh, the current passing through this LED and that is the supply voltage for LED and the Arduino Uno board will be different. So to balance the voltage, we can use this resistor. So just click on this resistor and just place here. So let me rotate it. Then you place it below the anode pin. Now another end of the resistor should be connected to the IO pin of the Arduino Uno board. So if you look into the Arduino board, starting from 2 up to 13, from this side, all these belong to digital input output pins. Similarly, here we have at the bottom we have A0 to A5, so which belongs to analog input pins. So if you want to read any analog values from any sensor, then you can connect to this, connect to any one of these pins. So now we need to connect this positive side of LED to input output pin, digital pins. So let me start from here and then connect to say pin number 5. So always the connection lines, if you consider this, the positive should be represented as through red color, negative through black color. So let me change this connection line color. You select that, then go to this colors drop down, then choose black. So now this, the next one. So we are not connecting it to supply voltage, we are just connecting it to IO pin. So let it be like this. If you are connecting another end to supply voltage, then change the color to red. So by using different colors, you can easily differentiate the connections and identify why we have connected in this way. So now we have completed the connection. So we are going to make this LED to glow repeatedly, make it on and off repeatedly based on a time delay. So next let us go to the code section. So click on this code button. So once you click, you have a drop down menu called blocks plus text, then text. So these are all the blocks. So you have two sections, on start and forever. So these two are on start is used for configuring the initial setups. Similarly, forever is used for doing a process repeatedly. For example, I want to configure this LED, the positive pin, that is input IO pin, as the output pin, because I want to write something or I want to pass some signal to the LED so that it should be turned on for a specific time period of time. Then again it should be made to be off. So this should happen repeatedly, but initially it should be So we have to make it as a output pin, and then so once we make it as output pin, we have to initially make it to be in off state. So that should be done within the on start block. Then the things to be repeated should be done inside the for hour block. So as of now, I can let me remove the blocks inside the for hour block. You just drag it and drop it into the dustbin. So first I need to set the pin number 5 to low. So here is the option, that is here is the block which you want to make use of for setting the pin number. So you just drag and drop the set pin block into the on start block. Now we have to set the pin 5, pin number 5. So initially the state should be low, which means that the LED should be in off state. High represents the on state. So now what should happen continuously? So this LED should be glowing on and off repeatedly. So for that again you just drag this set pin block inside this forward block. So now it should be set to high, that is pin number 5 should be set to high. So we can set up a time delay, that is for how much so how many seconds or how many milliseconds the LED should be in on state. So for that let me go to the control option. So there we have a block called wait. You just drag and drop it after the set pin block. So now you can change the time, default time 1 to say for example 5 seconds. Even you can change the second to milliseconds. So only if it is in seconds, then we can view the change of state. So now they should be repeated. So first initially it should be high for 5 seconds. Then again it should come back to low. So let me right click on this, then select duplicate, then put it after this wait block. So now what should happen? So this pin 5 should be in off state. So you select the option low. So here you can change the time. So let it be 7 seconds. So that's all about the coding part, I mean the logic. So now if you click on this drop down menu and choose block plus text, you can view both the block design and also the corresponding code here. So this setup method is equal to on start block. So what has been done is that the pin mode is set to output, which means that we are going to send some signal to the LED, write something to the LED pin. So next digital write method is used for changing the state of the LED pin. So initially it should be low. So it is connected to pin number 5 on the Arduino Uno board. So digital write of 5 comma low, pin number comma the state. Then this loop method is equal to for hour block. So first it is set to high, then a delay is introduced for about 5 seconds, that is 5000 milliseconds. Then again it is turned off by passing the low state. So it will be off for 7 seconds, that is 7000 milliseconds. So you can also view the equivalent code for whatever logic you have built using the code block. So now you can click on this code button so that it minimizes. So now let us check the simulation, that is check the output through the simulation. So you click on the start simulation button. So you can watch the LED glowing here for 5 seconds. So now it is off. This continues for 7 seconds. Then again it is glowing. So this will be repeated. So it happens continuously. So this is what called as blinking. LED will be blinking, that is on and off repeatedly. So let me stop the simulation and show you one more thing, that is how you can change the color of your LED. By default it will be in red color. So if you select the LED by clicking on it, you will be getting an option wherein you can give a name and then you can change the color here. So let me change it to green. So you can notice the change here. Again let me start the simulation to view the output. So now the LED is glowing for 5 seconds. Again it is turned off. So again it is glowing. So this happens continuously. So now let me stop the simulation. So whatever changes you do will be auto saved. You don't need to save anything. So this is the circuit view. You can click on the next option, schematic view. So this will be helpful for the EC or triple E or E&I students to get the actual circuit diagram. Similarly, you can get the list of components which you have used for your project or experiment. So I have used Arduino board, then resistor and then LED. So this will be very much helpful for your project documentation or experiment documenting your experiments. So now let me switch over to the class. Let me click on the back button. See, my design is available here. In the next video, I will show you how you as an educator can create an activity in your classroom so that your students can view the activity and learn through the activity. Thank you for watching.